Okay, please make sure to look at your formula sheet. You will get this on your test. That way you are familiar with everything that is given to you. So here's our day one practice. We have to match the function name with the shape of the graph. I'm going to make it smaller so I can see everything. There we go. Okay, so linear is a line. That is graph F. Exponential, you have either growth or decay. So that would be D. And there's a horizontal asymptote at y equals 0. Quadratic, that's a parabola. So that's C. Polynomial, C is technically a polynomial. Quadratics are polynomials, but we're going to look for a graph that has more maximums and minimums than just the one for a quadratic, and that would be graph B. Rational graphs have horizontal and vertical asymptotes, so that's graph E. Absolute value looks like a V, that's graph G. A log is the inverse of an exponential. So instead of having a horizontal asymptote, it has a vertical one, and that would be graph H. Trigonometric is like sine or cosine, so that's I, and radical is the square root. Notice how it has an endpoint here at 0, 0, so that's A. Okay, so for number 2, first I need G of 2, which is 2 plus 1. Then we're going to do F of that result, which is 3. So 3 squared is 9. For B, we need F of 2, which is 2 squared. And then we plug that into G. We get 5. For C, we're going to do F of G of X. So that means any x in the f function gets replaced with x plus 1. We're not going to leave that as x plus 1 squared. We want to simplify it. Anytime you have a binomial squared, it means multiply by itself. You can take your preference, pick your preference of methods. You can FOIL, you can box method, you can distribute. And as a final answer, you would get x squared plus 2x plus 1. And lastly, for D, we've got G of F. So that means the x in the G function gets replaced with x squared. Okay, so for 3, if we're going to be compounding monthly, the amount we're going to have is the initial deposit, 1 plus the interest rate as a decimal over the time period to the time period times years. And you're going to use your calculator to simplify this. And when you're typing that in your calculator, make sure that you put your entire exponent in parentheses, so that your calculator knows you want to raise it to the 12 times 10, and your answer should be $1,647.01. Round appropriately. Do not make a mistake on your test because of rounding. So compounding continuously is the initial deposit, E to the rate times time. Again, in your calculator, make sure you group your exponent with parentheses, and you will get $1,648.72. Now for number 4, they're giving us different information. Instead of giving you the initial deposit, we're getting the amount that we want in the end. So quarterly is 4 times a year. So what you have to do is find out this number in your calculator. I'm going to write out the whole decimal. You don't have to write it as long as in your calculator you use the answer or use the entire decimal when you finish solving. So we're going to divide by both sides by that 2.4 long decimal. So in your calculator, do 12,000 divided by the answer, and that way you would get the exact value. So that's $4,927.75. We're going to do the same thing for B. So that's 12,000 equals the deposit E, the 0.09 times 10. So we're going to find a value for this. And when you use your calculator, do 12,000 divided by the answer, and you're going to get $4,878.84. Okay, you have to pay close attention to the directions in 5. It says it's a polynomial. It's a very common mistake for students to write a sine or cosine function. I don't know why, because it's not a repetitive graph, it's not periodic, but it's a polynomial, so make sure on your test you read the directions carefully and you know what you're supposed to be doing. So for the polynomial, we're going to start in factored form, and we don't know the leading coefficient a, so I'm going to hold its spot. And then we're going to take our x-intercepts here and put them into the factored form. And now that we know the factored form of this polynomial, we can take our y-intercept at 8, because that's the 0.08, and plug it in to solve for a. And I get a is -1. So your final answer is -1 times x plus 4 times x plus 2 times x minus 1. Do the same thing for the second graph. We've got a y-intercept of 2 now. So when we divide both sides by 6, we get 1/3 for A. So your final answer is with that leading coefficient substituted back in. Okay, for day 2, we're going to sketch our exponential. Because of this 0.5, it's a decay graph. You can use your calculator to get that. There's a horizontal asymptote. So for our properties, the domain is all real numbers. You can write that as either all reals, or you can write the interval notation, -infinity to infinity. The range for the y's, that we start at 0 and go to infinity, but we don't include 0, which is why it's a curved bracket. The graph is continuous. This graph is always decreasing, and there is no max or min. Boundedness refers to if our range has an upper or lower bound, like if the graph is stopped either at the top or at the bottom. So this graph, because our range is only 0 to infinity, it's bounded below. There is no symmetry. The asymptote is y equals 0. It's a line. You have to write it as an equation. For end behavior, the limit as x goes to infinity, our function is going to, so as we go to infinity, our function is going to approach 0. And as we go to negative infinity, this way, our function is going to infinity. And it is not even or odd. Even refers to y-axis symmetry, and odd refers to origin symmetry. Okay, so now for number 2, the first 3 problems that we're going to solve here, we can make the bases the same. So 243 we can write as 3 to the 5th. And now that the bases are the same, we can set our exponents equal. So that's how I get an answer of x equals 5. 64 is 2 to the 6th. So setting our exponents equal and solving, we get x is 3. And 125 is 5 to the 3rd. So we get x is 1. And now for D, can you make 7 5 to a power? No, it's not a multiple of 5. So what we can do is if we log both sides, we can use a property of exponents where property of logarithms where the exponent becomes the coefficient. So solving, we get t is the ln of 7 divided by the ln of 5. And if you type that in your calculator, you get 1.209. We're going to do the same thing for E. If we log both sides, this t can become the coefficient. And then you type that in your calculator, you get 35.003. It does not matter if you use ln or log base 10. I just choose ln, but the problems would work exactly the same if you used log base 10. And now for F, you cannot log both sides until you get rid of that coefficient in front of the exponential term. And by get rid of, I mean simplify to move it to the other side. So 100 divided by 25 is 4. Now we could log both sides. And divide by the ln of 1.5. And we get 3.42. For number 3, we're going to use more properties of logarithms. When you have a product here in the argument, we can write out our log with addition. When you have division in the argument, that's subtraction. But so there's 2 ways to do B. Because you have a product in the denominator, if you include these parentheses, you can just do subtract the ln of B plus the ln of C, or you can distribute that negative, and you have minus ln B minus ln C. And then we're going to do the same thing for C, except now that we have these exponents, we have an extra step where the exponent becomes the coefficient. So instead of the square root of b, I can think of that as b to the 1/2. Let me just get some space here. So this is 4 ln A plus, so if this is b to the 1/2, the coefficient becomes 1/2, and then we have 5 ln of C. Now we can use the same properties to go backwards in number 4. So because we have an addition for A, we can rewrite that as ln of x times 3, but that x times 3 looks backwards, so we're going to write it as 3x. In B, this coefficient can come back and be the exponent, but it's the exponent on the entire 5x, which is why I do those parentheses. C I'm going to do in 2 steps. First, this coefficient becomes an exponent. And then the subtraction tells me I can rewrite it as a quotient with division. For 5, because it's log base 2, and I have an 8 that can be written as a base 2, what I'd like to do, so this is 8 to the negative 1 because of the fraction, but then I can rewrite 8 as 2 to the third, so that's really 2 to the negative 3. And now see how these bases are the same? Our answer is negative 3. In B, because of this property, and now ln of E, that's like saying E to what power is E? That's just 1, so this answer is negative 2. Now I can do the same thing for C, except you first have to use a property to expand the expression. And now, and this ln of E is 1, so we get 2 minus ln of 2. All right, and lastly, for sketching 2 periods, first I'm going to start with the amplitude. And I see that the amplitude is 4, so I'm going to go 4 up and 4 down. And then I need to figure out what my new period is. So the new period is always 2 pi over the B value. So that gives us a period of pi. So on my x-axis here, I'm going to go out to pi. And then since we have 5 critical points, I'm going to go halfway, halfway, and halfway. So what we can think is, what is half of 1/2? And that's pi over 4, or 1/4. So to get this missing one, we've got 1 over 4. This is 2 over 4. So this will be 3 over 4. And then lastly, we have 4 over 4, which is 1. I'm going to take the same scale back to the negative. And then cosine starts at a maximum, goes to the middle, back to the minimum, to the middle, to the max. I'm going to take that pattern backwards. And when you sketch the graph, make sure it's nice waves, it's not pointy. You want it to be nice and curved. Okay, so now for day 3, we need the slope of this between these 2 points, and slope-intercept form is that. So first let's find our slope. So we've got y2 minus y1, x2 minus x1. And that's a slope of 2. So now I always start in point slope form. I'll use this point because I find that easiest. And then simplifying this, we can switch it to slope intercept form. So I'm going to add the 4 to the right. So negative 12 plus 4 is negative 8. So for cost, we're going to look at fixed cost and variable cost. Variable cost is your slope of your cost equation, and fixed cost is your y-intercept. And then for revenue, that's how much you're selling your product for, because remember, we're always the perspective of the company. So if we're selling the posters for $5 each, we're going to earn $5 per poster for our revenue. And that's here. So profit, we use pi for profit. That's revenue minus cost. You have to be careful to group your cost function because this negative gets distributed, and it will make a difference if you don't have those parentheses. So our profit function is 3x minus 5,000. For the break-even point, that's when profit equals 0. So solving this, we get 1,666.6 repeating posters. Don't forget to label your answer. We're selling posters. Evaluating from a piecewise function, first we have to figure out for this 2, which piece of our function do we want to use? So is 2 less than 0? No. Is 2 greater than 0? Yes. So that's negative of 2 squared minus 2. That's negative 4 minus 2, so we get negative 6. And now for the bottom, negative 3. Is negative 3 less than 0? Yes. So we're going to plug that into the top piece. So we get 6 plus 1 is 7. Now number 5 is really 2 questions. We want a parallel and perpendicular line. But first we have to manipulate this equation so we can figure out what our slopes would be. So we're going to isolate the y. So I'm going to start by adding the 3x to the right. And then dividing everything by 2. So the only number we care about here is 3 over 2. So if we have got parallel and perpendicular, that's the symbol for perpendicular. And notice we want point slope form. So that's y minus 3 equals, then we have our slope and x minus 2. So for slope of parallel lines, the slopes are equal. For perpendicular lines, we want the negative reciprocal. And there's our final answers for number 5. And the last day, so we started the school year with these graphs from real life situations. So a train pulls into a station and lets off its passengers. Pay close attention to what is on the y-axis. It's our speed. So I don't quite understand why A is just floating in the air. And then B, this is slowing down gradually. C is it's slowing down and speeding up. And then D is it's coming into the station at a constant and immediately stops. So I say B would be our answer. Now for number 2, a woman climbs a hill at a steady pace and then starts to run down the side. So run down is a fast speed. Steady pace would mean she's going at a constant speed. So this is increasing speed, decreasing speed. So that's not the answer. This is increasing speed and then constant, which is backwards. So we're going to go with A. Here's her constant speed and then her increasing speed. And now for 3, a child swings on a swing. And notice now, instead of speed, we're looking at distance from the ground. So if you think of a swing, this is kind of, okay, so C is like what it looks like if you get on the swing, you go up and back and up and back. So the distance from the ground is changing. You're close here and then you're far away. Then you're close, then you're far away. So that would be A. We're close and then far away, close and then far away, close and then far away. All right, 4, 5, and 6 are more practice with logs. So for A, because we have a product as the argument, we're going to use the property where we can separate it with addition. For B, I have addition from the numerator, but then subtraction from the denominator. We have to go one step further and move this exponent. And then for C, again, we're going to have addition. I'm going to change that square root to a power of 1/2. And then all of these exponents become our coefficients. For 5, since A, we have the addition, we can write an argument with multiplication. X2 looks backwards, so we're going to write that as 2x. For B, this coefficient becomes an exponent to start. And then the subtraction, we write that as a quotient with division. And last but not least, for 6, for A, first we have to expand with our properties. And then I notice ln and e can simplify, and we're left with just plus 5. Now for B, we got the same piece that can simplify here. So that last term becomes a 2.